Welcome National 5, so this is Homologous Series Lesson 4. Just remember, make sure you are keeping on top of Lesson 1, 2 and 3, and they're all on the YouTube channel, so please check that out. Right, very quickly, starter. Question 1, write the general formula for the alkanes. Nice and easy, straightforward. Question 2, write the molecular formula for the alkane with 14 carbons, and then do the same for 12 hydrogens. Okay, so you'll need to use the general formula to work these two out. Okay, and then question 3, I want you to draw 2,2,4 trimethyl pentane. Okay, and then once you've done that, I want you to name that molecule there. So if you pause this video, do the questions, and then I'm just about to reveal the answer. Okay, answers even. Right, very first one, general formula, CnH2n plus 2. You need to know that. Yeah, CnH2n plus 2. Now, if we sub 14 carbons into there, it becomes C14. Okay, and then if we sub 14 carbons into there, it becomes 2 times 14, which is 28. Add 2, 30. So what we have is C14H30. Now, for the hydrogen one, this is my work in here, so the answer is C5H12. So 12 must equal 2n plus 2, yeah, because that's what H is. H is 2n plus 2, so 12 equals 2n plus 2. Now, we want to get n on its own because that's the number of carbons. Okay, so it subtracts 2 from that side, and then whatever we do to this side, we must do to that side. So that becomes 10 equals 2n. And then to get the n on its own, divide that by 2, but we also have to divide the other side by 2 as well. So n equals 5, and then n is the number of carbons, that's why it's C5H12. Okay, right. Now, this question here, 2,2,4 trimethyl pentane, always draw the longest chain first. So the longest chain is pent, which you should know hopefully by now is being 5 carbons. So 2, 3, 4, 5. Yeah, now it's up to you. You can number your chain if you want. Yeah, just put a wee small number. And then we've got a methyl group. Now you'll notice it's trimethyl. So what that means is tri means 3. So we have 3 methyl groups. And then methyl is a branch with just 1 carbon. Okay, so we've got 3 branches with just 1 carbon. Now where are they? They're on 2, they're on 2, and they're on 4. So if we draw one on 2, so that's a branch there. Yeah, and then also on 2, what mistake people tend to make is they put the carbon here. Okay, so they have 2 carbons in the one branch. That would make it an ethyl. So just be careful with that. We need to go under, and we put the branch on like so. And then we've also got 1 on carbon 4. So we place another branch on carbon 4. There you go, nice and easy. And then all you have to do is make sure every carbon has 4 bonds coming out it. Don't miss any, because again you will lose a mark. Nice and easy. Right, now this one here, we've got to follow our steps. Now remember, our first step is to identify the longest chain first. That's a mistake a lot of people make here. So if we start here, we've got 1, 2, 3, 4. 1, 2, 3, 4. Do we have a longer chain in that? Yes, we do. 1, 2, 3, 4, 5. Okay, so what I can do, just to show you this, I can highlight it like so. Now, I did start here, but I could also start here. So 1, 2, 3, 4, 5. Just to show that it doesn't actually matter, let's go up here instead. Okay, now what we need to do is we can circle our branches. So that's a branch, and that's a branch. Okay, now if we start our chain from the side closest to the branch, would we start from that side or would we start from that side? Now if we start here, 1, 2, 3, the first branch is on carbon 3. However, if we start here, the first branch is carbon 1, 2. Okay, so this side here is closest to the branches, so we make that carbon 1. Now, the longest chain's 5, so that makes it pentane. Okay, now that there, we've got 1 carbon, there we've got 1 carbon, so these two are both methyl. Now remember, because they're the same branch, we have 2 of them, so if we have 2 of the same branch, we call that di. Okay, and then what numbers are they on? They're on carbon 2 and they're on carbon 3, so this becomes 2, 3 dash dimethyl pentane. Okay, so well done if you got that. If you never, just go back over your notes, make sure you are checking your notes on a regular basis. Every night I'd recommend 5-10 minutes. Right, so our lesson today, what we're going to look at, we're going to look at shortened molecular formula. Now, we have already done this, however, we are going to step it up because we're going to look at the shortened molecular formula for branches. Okay, so just a wee recap, yeah, and I'm only going to do one example because it is very straightforward. Let's just say we have propane, like so. Again, prop means 3. If you don't know your prefixes, you really should by this point. So again, if we want to do the shortened formula, split to a dotted line between each carbon and then write what we see. So we see CH3, we see CH2, and then we see CH3. Okay, now you can write it like that, or you can put a bond in like so. It doesn't actually matter how you do it, it's the same thing. Okay, right, now this is sort of a wee note, and it will make sense when we start doing it. Branches are placed in brackets. Right, what we mean by that, if we go for an example 1, let's just go for, we'll do 3 carbons, but this time we'll put a branch in the middle carbon. So for anyone that can work this out very quickly, this is 2-methyl propane. 2 because it's on carbon 2, it's a methyl group, longest chain's 3-propane. Right, so what we do, very much like what we do before, in your longest chain, sort of split it up like so. Then we need to write what we see. So the very first bit, we see CH3, like that. Okay, now this is where it gets a wee bit trickier. What we do is we sort of separate, if I do it in a different pen, we separate the branch off like that, yeah, and then we write what we see that isn't the branch. So all we see there is CH, so we write CH, and then go back to our note. Branches are placed in brackets, so because it's a branch and it's CH3, we put that branch in a bracket, like so. So that's how we deal with branches, and then we carry on our longest chain. So there it is, CH3. Straightforward. Now, if I do another one, let's go for 4. Try and keep it small. I'm drawing so many H's, as are you guys, obviously. So we'll go for this molecule here, and you can pause it if you want to try and name it. However, this is 2,3-dimethyl butane. 2,3 because the branches are on 2 and 3. They're both methyl and they're the same, so it's dimethyl, and then the longest chain is 4-butane. So 2,3-dimethyl butane. Anyway, that's not the point of this. So again, separate our carbons out like so, and then what we can do, we can separate the branches as well. So we write what we see, always start on the left, so CH3, and then the next one, again we don't include the branch at this point, so it's just CH, and then the branch, what do we do with branches? We place them in brackets. So it's bracket, branch, close bracket, and then we move on. So we go here. So we'll do the longest chain bit first, so that's CH. And then we draw our branch in brackets. And then we carry on CH3, like so. Like that. Yeah. Now, another way you can get asked a question is you could be given this and then being asked to draw that. So if let me see if I can come up with one. Just go for this, okay? So that's our shortened molecular formula. Remember, we know we've got a branch because it's in a bracket. Yeah. So we draw it out. Now what I always like to do, I always like to draw the longest chain first. Okay, so what you do is you count the number of carbons that aren't in brackets first. So 1, 2, 3, 4. So that's our longest chain. 1, 2, 3, 4. Once we've got our longest chain, we just start putting in the hydrogens. So we start on the left. How many does this carbon have? Has 3. So we put in 3 hydrogens. How many hydrogens does the next one have? 2. So we do that. Yeah. What about the next one? It only has 1. Okay. Now, if it only has 1, what's going down here? Well, it's in a bracket, so we know it's a branch. So we put our branch in like so. And then our last carbon has got 3 hydrogens. And a wee sort of tip to note you've done this right is that the valencies need to still match up. So every carbon should have 4 bonds coming out it. Every hydrogen should have 1. Okay, and then very last one. Let's go for, make it a wee bit more challenging, I suppose, if you can call it that. Right, so again, let's do the longest chain first. So that's the number of carbons that aren't in brackets. Okay, so 1, 2, 3, 4, 5. So our longest chain is 1, 2, 3, 4, 5. Right, once we've done that, start on the left and then just add your hydrogens. The first carbon has 3 hydrogens. 1, 2, 3. Next carbon has 1 hydrogen. Okay, so what's going there? It's a branch because it's in brackets. So we do a wee branch like so, just like that, and then we carry on. Okay, so the next carbon has a hydrogen. What else does it have? Well, look at this. We've got a bigger branch now. How many carbons do we have in this branch? Well, we've got 1, 2. Okay, so this must be an ethyl branch, just like that. And then move on. Next carbon has 2 hydrogens, and then the last carbon has 3 hydrogens, just like that. Okay. I wasn't going to do another one, but it's literally just popped into my head, so I am. I'll draw it out this time though, so just make it, yeah, let's make it easier. So again, remember, if I'm going too fast, you can pause it to catch yourself up. That's the beauty of having a video. Okay, now again, we have drawn it, so let's separate our sort of carbons out, and we've got 2 branches, so we can sort of separate that. Right, now this one, the first one, is CH3. Yeah, do we see that? CH3. Now the next one along only has 1 carbon in its chain, but you'll notice there's 2 branches. Okay, now because there's 2 branches, we need to have 2 brackets. So the first one is CH3 bracket, and then because we've got another branch, we do another bracket. Okay, and then our last one, CH3, just like that. And that's how you do shortened molecular formula for branches. Okay, right, I will put questions at the end, don't worry. Now this next one, our heading is going to be cycloalkanes. Now if you did the National 4 work with your 3rd year teacher, this will be an absolute breeze. Okay, now what these are, obviously it's an alkane, so they contain, just like alkanes, they contain carbon to carbon single bonds. Yeah, now next one, they are in a Salic structure. Okay, and what we mean by that is it's a ring structure. Okay, and because it's a hydrocarbon, okay, it is insoluble in water. And if you can't remember from 3rd year, what insoluble means is does not dissolve in water. Okay, so very much like alkanes, cycloalkanes are insoluble in water, and you need to know that. Okay, right, now what we're going to do, we're going to do a wee table. So we've got number of carbons, we've got molecular formula, we've got structural formula, and we have, maybe if I put the name over here actually, Okay, now if I, sorry, get my ruler out if it can fit. I can barely see. Right, okay, so just make it neat, like that. Yeah, that's alright. So our first one, now to name cycloalkanes, we put the alkane name, but before it we write cyclo. So our very first one is cyclopropane, okay? And we're going to come on to why we don't get cyclomethane and why we don't get cycloethane, but you might have already worked it out, okay? So cyclopropane, because it's prop, it contains 3 carbons. Now, our molecular formula is C3H6, and our structural formula, what we do is we do 3 carbons in a ring shape. Now, 3 carbons, what shape has 3 sides? A triangle, so you do it in a triangle shape. Now, because that each carbon has 2 bonds coming out it, that allows for 2 hydrogens getting attached to each carbon, because remember, carbon can only have 4 bonds coming out it. So there is cyclopropane. Okay, now the next one, again, you've probably guessed it if you've done it already, or even if you haven't, cyclobutane. Okay, how many carbons does that have? Has 4, and the molecular formula is C4H8. And what side has 4? What shape has 4 sides? A square. So you draw it in a square shape, and then each carbon has 2 hydrogens coming out of it, like so. And there is your cyclobutane. Now, this goes all the way up to cyclooctane, however, I'm only going to take it to cyclopentane. Okay, now that's got 5 carbons again because of the pent, and what's the formula? C5H10. And then what shape has 5 sides? A pentagon. So you draw it as a pentagon shape, yeah, kind of looks like a house. And then make sure each carbon has 2 hydrogens coming out it, and that is your cyclopentane. Yeah, so easy. That is so easy. Now, what we do need to do now is we need to write the general formula. And again, it's a wee bit different from the alkanes. Now, alkanes are CnH2n plus 2. Okay, now if we look at this, what do we need to do to that 3 to get 6? What do we need to do to that 4 to get 8? What do we need to do to that 5 to get 10? All we need to do is times it by 2. 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. So our general formula is CnH2n. And remember, N equals number of carbons. So what we're doing is we're bringing in another general formula that you guys need to learn. Okay, so you need to know that the alkanes is CnH2n plus 2. You need to know the cyclos, well, the cycloalkanes, sorry, are CnH2n. Okay, now, last wee bit. Let's get rid of this. Yeah, there is a wee last bit. Now, we do not get cyclomethane/ethane. Okay, and is anyone able to work out why that's the case? It's because, remember, they have a ring structure, cycles. Now we can't form a ring with one carbon. We can't form a ring with two carbons. It's impossible. Okay, so the reason we don't get that is because we cannot form a ring structure with one or two carbons. Okay, so what that means is that cyclopropane, okay, cyclopropane is the first member of the cycloalkanes. Okay, now again, I'm just going to highlight that as well because that's very important. That's often a question. It'll come up, it'll be like, what is the first member of the cycloalkanes? And a lot of people say cyclomethane, but that's incorrect. The first member is cyclopropane because that's the first structure where we can actually get a ring structure. Okay, right, that is all I want to do sort of learning wise. Now what I want you to do, as we always do, is some questions. Like so. Okay, so very first question, let's see, what did we did the shortened molecular formula. Okay, so I'd like you to draw this here. Okay, so CH3, CH. I want you to draw that. Okay. Then I want you to draw this one here. I've run out of space. Draw that one. I'll leave a gap so I can put the, in fact no I won't. Question 2, I want you to name, oh, in fact, you know what? Let's just put draw and name, okay, for both of them. So I want you to draw and name that one, draw and name that one, please, okay. Question 2, let's go for nice wee easy one. Is I want you to write the shortened molecular formula. Okay, so for that one there, remember we do have a branch, so split your carbons like so, and then cut off your branch, and then draw your branches like that. And then question 3, let's go for A, write general formula for cycloalkanes. Now if you can do this without looking on the previous page, that'd be good. So write general formula for the cycloalkanes, and then I want you to draw. We've not done this, so let's see if you can draw cyclohexane. Okay, remember it's hex, so what's the prefix for hex? You're going to have to find that. You should already know that, but give it a go, and that'll be us. Right, thank you.